My dear student, I told in previous class we have to get the equivalent resistance of a given network. How can we proceed the problem related with this? In 12th class, chapter 3, current electricity, the very important part in given electrical circuit, then we have to get the value of equivalent resistance of a given network. And so, here two important numericals. In these two given numericals, we have to get the value of equivalent resistance. In previous class, we know that in series connection, the equivalent resistance will be equal to their algebraic sum, and already we see in parallel connection what would be the value of equivalent resistance. In these two given electrical circuit, we have to get the value of equivalent resistance. See this in this problem. At first, we select the point or junction in electrical circuit. How can you get the value of point and junction? How can you select? If three wire at least will meet at a particular point. If three wire at least will meet at a particular point, and that will be point or junction in electrical given network. Here we see 1, 2, 3 will meet at this point, and so it will be P, and we see here 1, 2, 3, then it will be Q. But here only two wires are joined, and so it will not be point. You remember it? For the selection of the point or junction in given electrical circuit, at least three wires will meet at that point. And now we make the new electrical channel. And you see here, very important step, you have to see M and N. Across these two terminals, we have to get the value of equivalent resistance. But this wire has no any resistance and connected with two points M and Q, and so M and Q will be the common point. Similarly, this wire has no any resistance, but it is connected between P and N, and so P and N will be common point. And now we make the new electrical circuit as according to given questions. As M and P is connected with R, and so M and P we make a wire of resistance R. P and Q is connected with R, and so P and Q here, so we make a wire of resistance R. And Q and N is connected with this R, and N and Q here, and so a new wire is connected. Just we see clearly these three resistances are in parallel, and I already discussed in previous class. For n equal resistances are connected in parallel, then its equivalent resistance will be decreases n times. And so here clear Rmn will be equal to R by 3. It is the required answer. And so this step is most important. A student has no idea how to proceed this type of problem. So first of all, we just make the electrical circuit as according to this concept. Just again you remember already, the wire has no any resistance, are connected at 2 points. Then 2 points will be at a common point. And now we will get easily this type of problem. So clear. Now just I am coming in this given electrical circuit. We see here R1, R2, R1, R2, R1, R2 just going to infinity. How can proceed this type of problem? And here given the data, R1 will be 4 ohm, R2 will be 3 ohm. Then we have to get the value of equivalent resistance across Mn. And now we proceed here. First of all, we make the new electrical channel. Except these two resistance, just you remember. If one resistance is given here, given here, given here, no any problem. Then this. Now just other channel. And so here R1 and R2. We will make the new circuit here, R1 and R2. And now for infinite channel, its equivalent resistance will be equal to R, and which is unknown. We have to get the value of equivalent resistance of this circuit across Mn. So this type of problem you make at first the electrical circuit. Except these two resistances, let us suppose that for infinite chain its equivalent resistance R. And now we know that, and we see here R, R2 which are connected in parallel. So its equivalent resistance will be equal to R, R2 and divided by R plus R2, because for two resistances are connected in parallel, then its equivalent resistance will be product upon sum. And the equivalent resistance of these two resistance which are connected with series, and so it will be equal to plus R1 and will be equal to R. And now putting the value of as according to given data, R1 4 ohm and so R2 3 ohm, 3 into R, and divided by R plus 3 plus R1 4 will be equal to R. Now LCM R plus 3 and 3R plus 4 into R plus 4 multiply 3, 12 will be equal to R. R multiply R, that will be R squared. 3 multiply R, that will be 3R, will be equal to 3R plus 4R, 7R, 7R plus 12. And so equation R squared minus 3R minus 7R, 3R minus 7R, that will be minus 4R plus 12 will be equal to, minus 12 will be equal to 0. 3R minus 7R minus 4R and minus 12 will be equal to 0. And it is quadratic equation. And so we will get the value of R 2, because the maximum power of R here 2, and so R has 2 value as R square minus 4R minus 4R, it can be written minus 2R plus 2R minus 6R, minus 2R plus 6R, 6R minus 2R plus 4R, no, plus 2R minus 6R, 2R minus 6R will be equal to minus 4R. So here we just adjust here this figure, R square plus 2R minus 6R, minus 12 will be 0, and now R will be common, R here plus 2 minus here 2 R plus minus 6 will be common, R plus 2 will be 0, and so R minus 6 into R plus 2 will be 0. So either the product of R minus 6 and R plus 2 will be 0 here. And according to concept of mathematics, either R minus 6 will be equal to 0 or R plus 2 will be equal to 0. But you remember already, the resistance of a conductor can never be negative. And so if R plus 2 will be 0, then R minus 2 and it is not possible. And so this resistance value is rejected already. But if R minus 6 will be 0, so R is equal to 6 ohm, and this is the answer. So my dear student, just I get already the value of equivalent resistance across Mn is 6 ohm. Now we have already these equations, and here 4 ohm, 3 ohm, and we get here the value of R is 6 ohm, and it will also equal to equivalent resistance across Mn. For example, if putting the value of R here 6 ohm, now we will get the value of equivalent resistance across Mn, then it will must be equal to 6 ohm. For example here, now we have to get the equivalent resistance across Mn. Here these two resistances are in parallel, so its equivalent 6 multiplied 3 upon 6 plus 3, and the equivalent resistance of these two resistances which are in series, so plus 4, here 18 upon 9 plus 4, 9 2 plus 4, 9 2, 2 plus 4, that will be 6 ohm. Just we see here, except these two resistances, the equivalent resistance for infinite chain we get already 6 ohm. And now this value is putting as according to the given network, so the equivalent resistance across Mn will be equal to 6 ohm. And so my dear student, if you have an idea how can proceed any problems in physics, then you take a step and do hard labor. I am Mr. Dhananjay Kumar, PGT Physics from Urban School, Darbhanga.